Hello students, welcome to Educate. In this video, we will discuss about alcohol, phenols and ethers. Now let's start the chapter alcohol, phenols and ethers. Let's see what is firstly introduction. What is that? As you know, haloalkane and halorine I have taught you. So in that case, same, when halogen was bonded to open chain hydrocarbon, we have told them haloalkane, and when the halogen was bonded to the aromatic hydrocarbon, we have called them as haloarine. In the same way, here is what is OH. OH is called here OH minus. That is called hydroxyl group. Hydroxyl group. OH minus ion you have told also. Hydroxide ion. Hydroxide ion you have told here. When it was in the solution, we have told them as hydroxide. And when the OH minus ion, will be bonded, will act as a group, then that will be called hydroxyl group. So this hydroxyl group it is. So when this hydroxyl group will be bonded to the open chain hydrocarbon, or that means aliphatic hydrocarbon, then that will call alcohol. When the hydroxyl group will be bonded to the open chain hydrocarbon or the aliphatic hydrocarbon, then that will be called alcohol. It is also alcohol. And when the hydroxyl group will be bonded in benzene, or that is aromatic hydrocarbon, then that will be called phenol. When OH will be bonded to aromatic hydrocarbon, then that will be called phenol. Okay guys, that was alcohol and phenol. And what is ether? Ether here, where there is oxygen here, both sides there will be alkyl group. In case of ether, both sides the alkyl group will be present. When there will be alkyl group in both the sides of oxygen, then that will be called ether. What was about the alcohol? In one side there was alkyl group, and other side the hydrogen. One side alkyl group, another side hydrogen. So that was called alcohol. And when both the sides there be alkyl group, then that was called ether. That was about the introduction. Now let's see classification. About the classification, we have already discussed in the haloalkane, and same manner will be here. So I hope anyone will not feel any difficulty. So I am teaching this one is fast. So just we will have to go through. So one is here on the basis of number of halogen atom, on the basis of number of hydroxyl group in the compound. First of all, let's see about that. On the basis of number of hydroxyl group. So if in the compound there will be only one OH, then that will be called monohydric. If in the compound there will be two OH, that will be called dihydric. And in the same way, if there will be three OH group in the compound, then that will be called trihydric. There was called monosubstituted haloalkane. Here it will be called monohydric alcohol. If two OH group in the compound, then that will be called dihydric alcohol. And in the same way, if there will be three hydroxyl group in the compound, that will be called trihydric alcohol. Now let's see here. Next point is here, compounds containing CsP3OH bond. That means here the alcohol in which, that means we are classifying the compounds in which the hydroxyl group will be bonded to that carbon atom whose hybridization will be sp3. How to predict the sp3 hybridization? We have discussed already that if the carbon atom will do sigma bond formation, that means if the carbon atom will form 4 sigma bond, then hybridization will be sp3. Or if, that means always the hybrid orbital will either do sigma bond formation or will contain the lone pair of electron. So here, so compounds containing CsP3OH bond, that will be of three types: alkyl halide. Oh, there was alkyl halide. Here it will be called alkyl alcohol. Alkyl alcohol. Same here, allyl alcohol on benzyl alcohol. Now the alkyl alcohol, that will be of three types. That means here 1 degree alcohol, 2 degree alcohol and 3 degree alcohol. Based on that, the OH is bonded to 1 degree carbon or 2 degree carbon or 3 degree carbon. Based on that, the alcohol will be classified as primary or 1 degree alcohol, secondary or 2 degree alcohol, tertiary or 3 degree alcohol. About that, you are acquitted. That means that is not new for you. Now let's see here, allyl alcohol. Among what is allyl group? We have discussed that in allyl group there will be a carbon atom whose hybridization will be sp3. That means there will be a carbon atom which will do only sigma bond formation, but that carbon will be bonded to sp2 hybridized carbon. Then that group will be called allylic group. Allylic group means there will be a group in which the carbon will be bonded to other group whose hybridization is sp3, but that will be bonded to sp2 hybridized carbon atom. About that, you are already acquainted about that. So let's see here. So that is can be also classified into primary, secondary and tertiary alcohol. If you are feeling the difficulty, then firstly you watch out the video of haloalkane and haloarine, and even though if you are facing any difficulty, even though if you are not confident, then after consult the Educate YouTube channel. Now benzylic alcohol also, you know, like benzyl halide, there is benzylic alcohol, or benzylic halide, same as benzylic alcohol here. So that can be also 1 degree, 2 degree and 3 degree. That means benzyl alcohol means the OH group will be not directly bonded to the benzene. That will be bonded to that carbon atom which will be bonded to the benzene. Here in case of benzylic alcohol, the hydroxyl group will be bonded to that carbon atom which will be bonded to the benzene. Then that will be called benzylic alcohol, and that may be primary, secondary or tertiary. So same here, this one, primary, secondary and tertiary, you already know that primary carbon atom, the carbon atom which will be bonded to only one carbon or which will be not bonded to any carbon atom, like in methanol. This is also primary alcohol because here it is bonded to primary carbon, because this carbon is not bonded to any other carbon atom. And here this one, it is also primary alcohol because OH is bonded to carbon atom. And how this one is primary carbon? Because this carbon is doing bond formation with only one carbon. So it is also primary alcohol. So that is here primary alcohol, secondary alcohol and tertiary alcohol. You are already aware. Now vinylic alcohol, like in vinyl halide, you have studied that the halogen was directly bonded to sp2 hybridized carbon. So in the same way, in case of vinylic alcohol, the hydroxyl group will be directly bonded to the sp2 hybridized carbon atom. That means of the open chain. The OH will be bonded to sp2 hybridized carbon atom of the non-aromatic compound. So that is vinylic alcohol. And about the phenol and the introduction, we have already discussed that the OH will be directly bonded to the benzene. So that is here. Also further classified into monohydric, then here dihydric, trihydric. That is. Now let's see about the classification of ether. Ether is classified into two parts, that is simple ether, or that is also called symmetrical ether, and the mixed ether, also called unsymmetrical ether. Ether is classified into simple ether and the mixed ether. Simple ether is also called symmetrical ether, and the mixed ether is called unsymmetrical ether. So what is here? How that is symmetrical ether and unsymmetrical ether. If the alkyl group bonded to the carbon atom will be of same length, then that will be called simple ether or symmetrical ether. Like this oxygen here, this one oxygen here, this side is alkyl group which is composed of 3 carbon, and here is also alkyl group which is also composed of 3 carbon. So this ether is called symmetrical ether or simple ether. That means here the oxygen atom, if the alkyl group bonded to the oxygen atom will be of same number of carbon, then that ether will be called symmetrical ether or simple ether. But if the length of the carbon atom bonded to the oxygen will be of different, then that will be called mixed ether or unsymmetrical ether. Like that, if the compound will be so here in this compound, in this ether, one side there is ethyl and other side is butyl. So both length of both the alkyl group is different. The length of both the alkyl group is different. That's why this is an example of unsymmetrical ether. As in this compound, the alkyl group bonded to the oxygen is of different length. That's why this compound is an example of unsymmetrical ether or mixed ether. Okay guys, as you have already studied about the number of concepts in the chapter of haloalkane and haloarine, then I hope you have not faced any difficulty. Even though if bigger head problem you are facing, then once again watch out the initial video of the chapter haloalkane and haloarine. Now let's see. Now proceed on the question here. Primary, secondary, tertiary alcohol, I think very easily you can do. So here this is primary alcohol, primary, secondary, because OH is bonded to secondary carbon. Here it is tertiary because OH is bonded to the tertiary carbon atom. So that's why it's tertiary alcohol. Now, so that question was very easy. Now let's see about here this nomenclature. So we will have to consider about the nomenclature. Now let's see. Watch out this compound. How to write? Now by this one here we will discuss. The OH, OL, for the OH, for the hydroxyl group, when there will be the alcohol, then when there will be alcohol, then the suffix "ol" uses. Then the suffix "ol" uses for the alcohol. The suffix is "ol." As for here, OH is bonded to the methyl, so that's why IUPAC name is methanol. And common name is alkyl alcohol. In alkyl that here common name, in the common name we use alkyl alcohol, and the IUPAC name, in case of IUPAC name E of alkane, will replace by all. Like methane, A and E will replace by all. So here CH3OH, if that would be methane, so that will be methane. So and when OH will replace the one hydrogen, then A and E will replace by all. So compound will be called methanol. Okay guys, now let's see, watch out this question. Here in propane, OH is bonded here, so that will be called propane 1-ol. At first position, OH is bonded, so that will be called propane 1-ol. Here, when you have to write, so OH is bonded to this carbon. Whenever you will have to write the IPAC name, then you will have to select that longest carbon chain. Then you will have to select that longest carbon chain which will contain the functional group. So in this compound, OH is bonded to this carbon. So this carbon must be included. This carbon must be included in the main chain. So here will be 1, 2, 3 position, and alcohol hydroxyl group is present at second position. So that's why its name will be propane 2-ol. So here IPAC name will be propane 2-ol. And common name here, it's isopropyl, because if this will be the compound, so simply we will tell propanol. Oh, propanol will be the IPAC name, and in common name we will write propyl alcohol. That is here. But the OH is bonded to the secondary carbon atom. In this case, OH has been bonded to the secondary carbon atom. So it will be called, common name will be, so it is isopropyl here. With the isopropyl, the OH is bonded. That may be considered. So that's why it is called isopropyl alcohol. And propane 2-ol, because the OH is bonded. OH is bonded to second carbon atom. That's why it's called propane 2-ol. This compound very easy. You can do by yourself also. Very easy this compound. Butane 2-ol and secondary butyl alcohol. Here it is isobutyl alcohol. Here secondary butyl alcohol, because OH is bonded to the secondary carbon atom. This carbon is secondary, because this carbon is bonded to this carbon and this carbon. This carbon is doing bond formation with this 2 carbon. That's why it is secondary butyl. And OH has been bonded to the secondary carbon atom. So that's why called secondary butyl alcohol. And why butane 2-ol? Because in this case, the OH is bonded to the secondary carbon. 1, 2, 3, 4. You will have to do numbering in such a way that the functional group will acquire lowest position. As in the previous cases, you have already seen. In the same way, during the nomenclature of alcohol, you will have to do the numbering in such a way that the carbon containing functional group will acquire lowest position. Okay. Next point here. This one is to the isobutyl. Here of isobutane, hydrogen of primary carbon atom has been replaced. So that's why this is isobutyl group. So that's why the compound is called isobutyl alcohol. And when have to write the IPAC name, then obviously you will have to do firstly the numbering. So main chain will be 1, 2, 3. This carbon must be included in the main chain. And then after from here, you will have to proceed to the most lengthy carbon. So most lengthy. So 1, 2, 3. So here is methyl. So it will be 2-methyl propane 1-ol. So that's why 2-methyl propane 1-ol. Now let's see about this compound. In this compound here, it is tertiary butyl because this one here, OH is bonded to the tertiary carbon atom of butyl. So this is called tertiary butyl and it is alcohol. So a common name will be tertiary butyl alcohol. And how to write the IPAC name? So when you will have to write the IPAC name, then you will have to keep in the mind that this carbon is bonded to the functional group. So this carbon must be included in the main chain. So you will have to select that longest carbon chain which will contain this carbon, and that is possible. Either you go 1, 2, 3 or 1, 2, 3 or 1, 2, 3, whatever you would like. So when you will contain 1, 2, 3, when you will write this one 1, 2, 3, so this will act as substituent. So the substituent methyl is at second position and OH is also at the second position. So we will write 2-methyl and propane 2-ol. So that's why name is 2-methyl propane 2-ol. Now let's see about this compound. Here this carbon, here is OH, here is also OH. So this carbon must be included in the main chain and this carbon is also included in the main chain. So during the IPAC nomenclature, what to do? You will have to do the number 1, 2 or 1, 2, doesn't matter. So at first position there is ol and second position also there is alcohol. So that's why we will write ethane 1,2-diol. And in the common name, ethylene glycol. When in the compound there will be 2 OH group. When in the compound there will be 2 OH group, then that is called glycol. And if there will be 3 OH group, then that is called glycerol. So here 2 OH group is attached here. In this compound there is 2 OH group. So that's why that will be called glycol. And here 2 carbon. So that's why ethylene. Here 3 OH group. That's why glycerol. IPAC name 1, 2, 3 or do 1, 2, 3, whatever with that. Either you do the numbering here from left to right or from right to left. Doesn't matter. Then that is propane. Keep in the mind here. Here is also ethane. E has been retained here. Here also. When there will be more than 1 OH group, if in the compound there will be more than 1 OH group, then E of the alkane will retain. Why? Because between vowel here there is consonant K. So that's why E has been retained. So ethane 1,2-diamine. Keep in the mind here also. Always never do the mistake. In the IPAC nomenclature, there will be difference in the spelling and a number of students do the wrong response due to that silly mistake. So always keep in the mind, if in the compound there will be more than 1 OH, then E of alkane will retain. So that's why it is ethane 1,2-diamine. Here also E has been retained. So propane 1, 2, 3 triol. About this compound here. So how to write? OH has been bonded to the cyclohexane. So that's why cyclohexanol. Now here not only OH has been bonded. So you have to do the numbering. That means the carbon atom of cycloalkane which is bonded to the OH, that will get first position. And then after you go clockwise or anti-clockwise. In any direction you can go, but you will have to give lower position to the substituent. So here is second carbon atom. So at second total here it is cyclopentane. So that will be called cyclopentanol. But here there is a substituent also which is at second position. That's why this compound will be called 2-methyl cyclopentanol. I hope this one clear, and I think a number of students will consider that how much easy questions sir is teaching. Now let's see here IPAC name of phenol. So here when OH attached to the benzene, that we call phenol. When OH attached here, so this is methyl. So when you will have to write the IPAC name. So during that course, here 1 and it is 2. So that will be called 2-methyl phenol. So 2-methyl phenol, and when methyl group and OH group both will be present in the benzene. When the methyl group and the hydroxyl group both will be bonded to the benzene, then that is called cresol. And you know, they are here at ortho position with each other. That's why that is called orthocresol. When the methyl and the OH, both the group will be bonded to the benzene, then the compound will be called cresol. And here, since the methyl group and the hydroxyl group are at ortho position with respect to each other, that's why it's called orthocresol. Same here, metacresol and 1, 2, 3, 3-methyl phenol. Paracresol and 1, 2, 3, 4, 4-methyl phenol. Very easy. Now, when the 2OH group bonded to the benzene, then that is called catechol commonly. So here that is when the 2OH group bonded to the benzene at ortho position with respect to each other, then that will be called catechol. But what is that called here? So how to write the IPAC name? So 1, 2. So in the benzene there is 2OH group. So that's why that will be called benzene 1,2 diol. When here same, when 2OH group present to the benzene with respect at meta position with respect to each other, then that will be called resorcinol, or IPAC name 1, 2, 3 or 1, 2, 3, whatever you, in which manner you want to do the numbering. So that will be called benzene 1,3 diol. Same here, when the 2H group present at para position with each other, then that is called hydroquinone or quinol. Hydroquinone, and in the quinone there is 2 hydrogen. That's why that is called hydroquinone, or that is also called quinol. And IPAC name 1,4 benzene 1,4 diol. Okay, that was about the IPAC nomenclature of alcohol and phenol. All of you do the question in your homework. Do the question of exercise related to nomenclature of the exercise. There is first or second questions that you solve at your home, and I hope very easily you could solve the questions. But even though I will discuss in the next video. It's all for this class. Thank you, Team Educate.